Inside Porsche's factories, precision is not a slogan. It is a measurable standard enforced at every stage of production. These facilities are designed around one core belief. A performance car is defined as much by how accurately it is built as by how fast it is driven. Porsche's manufacturing philosophy prioritizes control over scale. While production volumes are significant, each vehicle is treated as an individual system rather than a unit on a line. The factory is structured to support repeatable precision while allowing controlled human intervention where it adds value. Every Porsche begins its life as a fully simulated digital model. Structural loads, thermal behavior, vibration characteristics, aerodynamics, and drivetrain dynamics are modeled long before physical assembly begins. These simulations define tolerances, material choices, and process parameters that the factory must execute exactly. Body construction starts with lightweight materials engineered for stiffness and balance. Aluminum and high-strength steel components are laser-measured before assembly. Robotic welding and riveting systems join the body-in-white with micron-level accuracy. Structural rigidity is engineered to support both performance driving and long-term durability. Automation dominates the early stages, not for speed, but for consistency. Robotic systems apply welds, rivets, and sealants with repeatable force and placement. Vision systems verify alignment continuously. Any deviation outside specification is corrected immediately or removed from the line. Corrosion protection is built into the structure. Body shells pass through multi-stage pretreatment and electrodip coating processes that ensure uniform coverage in cavities invisible from the outside. This foundation determines how the car ages over decades, not just how it looks on delivery day. Paint application is treated as a precision process, not decoration. Porsche's paint booths operate under tightly controlled airflow and humidity. Robotic systems apply base coats and clear coats evenly, while sensors monitor thickness and surface quality in real time. Human specialists intervene only where microscopic correction is required. Powertrain assembly represents a transition point where automation and craftsmanship intersect. Engines are assembled with strict torque control and dimensional verification. Critical rotating components, crankshafts, pistons, and connecting rods are balanced precisely to minimize vibration at high engine speeds. Each engine is treated as a performance instrument. Assembly parameters are logged digitally, linking every fastener and component to its build record. This traceability allows Porsche to correlate performance data years later with specific assembly conditions. Transmissions are assembled with equal discipline. Gear sets are measured, aligned, and tested to ensure smooth engagement and long-term reliability. Dual clutch systems are calibrated for response accuracy rather than raw shift speed alone. Chassis assembly follows a modular approach. Suspension components, steering systems, and braking hardware are integrated onto the rolling chassis with torque-controlled fastening. Alignment geometry is set precisely before the body and drivetrain are joined. The marriage station, where body and powertrain become a single vehicle, is one of the most controlled moments in the factory. Robotic lifts and guided alignment systems ensure that connection points meet exact specifications without inducing stress. Interior assembly introduces controlled craftsmanship. Wiring harnesses follow predefined routing paths to prevent interference and long-term wear. Dashboards, controls, and interfaces are installed and tested immediately for function and response. Leather and trim components are inspected for consistency, fit, and tactile quality. Porsche treats interior feel as part of the driving system, not an aesthetic afterthought. Switch resistance, steering wheel feedback, and pedal feel are engineered deliberately. Throughout assembly, quality checks are continuous rather than sequential. Optical inspection, torque verification, and functional testing occur at multiple points. Errors are not passed downstream. They are resolved immediately. Human expertise remains essential. Technicians and engineers monitor process stability, investigate anomalies, and refine parameters. Automation executes tasks. Humans enforce standards. By the end of assembly, a Porsche is not simply complete. It is structurally aligned, mechanically integrated, electrically verified, and digitally documented. The vehicle is prepared not just to run, but to be proven. That proof begins when the car is tested under conditions that replicate real performance demands. If this inside look at how Porsche assembles its precision cars gave you a new perspective on automotive engineering, make sure to like the video. Once assembly is complete, Porsche vehicles enter a phase where craftsmanship gives way to measurement. Inside Porsche's validation facilities, every assumption made during design and assembly is challenged. This stage exists to answer a single question. Does this car perform exactly as engineered, under all expected conditions without compromise? Validation begins with dimensional and structural verification. Completed bodies pass through scanning tunnels where thousands of reference points are measured in seconds. These scans confirm that the vehicle geometry matches digital specifications precisely. Any deviation, even one invisible to the eye, triggers investigation. Powertrain testing follows immediately. Engines are started for the first time in sound-isolated chambers. Cold start behavior, idle stability, vibration, and exhaust characteristics are analyzed. Sensors capture data across the rev range to ensure combustion stability and mechanical balance. Rolling road dynamometers simulate real driving loads without leaving the factory. Acceleration, sustained high-speed operation, and deceleration cycles are executed under controlled conditions. Engineers monitor power delivery, drivetrain losses, thermal behavior, and response latency in real time. Thermal validation is critical. Vehicles are subjected to heat and cold cycles that simulate global operating environments. Cooling systems are stressed under sustained loads, ensuring that temperatures remain within design limits during aggressive driving or extreme climates. Chassis systems are tested dynamically. Suspension geometry, damping response, and steering accuracy are measured on test rigs that replicate real road inputs. Adaptive systems are validated across multiple drive modes to confirm that electronic control aligns with mechanical intent. Brake systems undergo repeated high-load testing. Pressure, fade resistance, and pedal feel are evaluated under simulated track conditions. Carbon ceramic and high-performance steel braking systems are tested to ensure consistency over repeated cycles, not just peak performance. Noise, vibration, and harshness testing isolates cabin acoustics. Specialized chambers analyze how sound travels through the structure at different speeds and loads. Engineers refine insulation, mounting points, and damping materials to achieve Porsche's distinctive balance between mechanical feedback and refinement. Electronic systems are validated in parallel. Infotainment, driver assistance features, and vehicle control software are tested under full load conditions. Fault injection scenarios simulate sensor failures, communication interruptions, and edge cases to confirm system resilience. Water intrusion testing pushes sealing systems to extremes. Vehicles pass through high-pressure spray tunnels that simulate torrential rain and high-speed water impact. Drainage paths, door seals, and body joints are evaluated for long-term reliability. Corrosion resistance is validated using accelerated exposure tests. Salt spray chambers simulate years of environmental exposure in compressed timeframes. These tests confirm that structural and cosmetic integrity will be preserved well beyond initial ownership. Alignment and calibration are finalized after testing. Will geometry, steering angles, and sensor alignments are set with laser-guided systems. This ensures that handling characteristics match engineering targets exactly. Every test generates data. Performance metrics, anomalies, and environmental responses are logged and linked to the vehicle's digital build record. This traceability allows Porsche to correlate field data later with factory conditions. Human oversight remains decisive. Engineers review results, approve deviations only where justified, and refine test thresholds continuously. Automation accelerates validation. Accountability remains human. Only after a vehicle demonstrates stability across all validation layers is it approved to move forward. But controlled testing, even at this level, cannot fully replicate the complexity of real driving. True proof comes when cars leave the factory and operate in the hands of drivers around the world. If you want to see how real-world data shapes the future of Porsche engineering, make sure to subscribe. When Porsche vehicles leave the factory, engineering does not stop. It enters the environment that ultimately defines success: real-world driving. For Porsche, customer use is not separate from manufacturing, it is an extension of it. Every vehicle deployed becomes part of a global feedback network that continuously informs future design, testing, and production decisions. Once on the road, vehicles generate operational data across diverse conditions. Engine performance, drivetrain behavior, thermal response, suspension dynamics, braking efficiency, and electronic system reliability are observed over time. This data reflects real usage patterns, not controlled simulations. Digital twins evolve using field data. Models created during development are updated to reflect how vehicles behave under different driving styles, climates, and road conditions. When real-world performance aligns with predictions, confidence is reinforced. When deviations appear, engineering assumptions are revisited. Where patterns provide critical insight, component longevity, material aging, and tolerance drift are analyzed across fleets operating globally. These observations influence material selection, lubrication strategies, and assembly parameters in future production cycles. Software plays an increasing role. Over-the-air updates allow Porsche to refine control logic, improve efficiency, and address edge cases without hardware changes. Manufacturing must anticipate these updates, ensuring that vehicles are built with sufficient headroom for future software evolution. Manufacturing responds directly to field feedback. Assembly tolerances are refined. Calibration targets are adjusted. Validation protocols evolve to better reflect observed operating conditions. Factories become adaptive systems that learn continuously from deployed vehicles. Scale amplifies learning. Performance trends that may be subtle at small volumes become clear when thousands of vehicles are analyzed together. This allows Porsche to identify systemic risks early and implement corrections across production lines. Safety intelligence evolves alongside performance data. Real-world incidents, even rare ones, inform improvements in structural design, braking systems, and electronic safeguards. Lessons learned are integrated into both product architecture and factory validation processes. Sustainability is informed by lifecycle data. Real-world fuel efficiency, energy consumption, and component replacement rates shape future engineering targets. Manufacturing processes are optimized to reduce environmental impact without compromising performance. Human expertise remains essential. Engineers interpret data, validate automated insights, and make design decisions. AI systems assist by identifying patterns, but accountability remains with experienced professionals. Future Porsche factories are designed around this closed-loop model. Design, manufacturing, validation, deployment, and optimization operate as a single continuous system. Each generation of vehicles benefits from the experience of the previous one. Innovation becomes cumulative. No car exists in isolation. Every Porsche on the road contributes intelligence that shapes future performance standards, materials, and manufacturing techniques. In this model, precision is not static. It evolves through evidence, discipline, and iteration. From factory floors to mountain roads and race circuits, Porsche's approach demonstrates how precision cars are built, not just to perform once, but to perform consistently over time. If this inside look at how Porsche builds precision cars changed how you see automotive engineering, leave a comment with your thoughts.